Good morning, everybody. I am Anusha, Assistant Professor of CSE Department, Institute of Aeronautical Engineering. In my videos, we'll be discussing about programming with objects, which is based on Java. So, in the previous class, we have discussed about the basics of classes and objects, constructors, methods, and how parameters can be passed between them. Now, for today, we will discuss about static fields and methods, the various access control provided in encapsulation, and what is the use of this keyword. Now, let's look into use of static variables and methods. So, why do we declare any member as static, or what will happen when we declare any method or a variable as static? We have seen in our programs before, the main method is always declared as static. Why do we do that? We declare any member as static so that they can be accessed before any object of it is being created. So whenever we declare any variable or any method or any member as a static member, then we don't have to create any object for that to access that particular member. We can just use the class name in which it is being declared. So we declare main as static so that the JVM can invoke main method without creating an object of the class which is just being declared. So that is the main reason why we declare main as static. Now also this static member aids in memory management. Why memory management means these static variable will be always shared among the objects. It is a shared member. Usually when we create an object for a class, if there are 3 objects created, 3 copies of all the members will be created for each object. But if that member is a static member, only one single copy of it will be created and no other only single copy will be created, and all the objects will be sharing the same memory. Now we can apply a static keyword on a block, on a variable, or on a method. Now if we apply a static keyword on variable, then they are called as class variable, and on method it is called as class method. And all these static members are loaded at runtime. Now, when we apply static keyword onto a static block, then that is the one which will be executed first or loaded first when the class is being loaded onto the memory. So the static block always gets executed first. And we can also initialize our static variables in this static block. And it will get executed exactly once. It will be executed only once. And these blocks are loaded even before the main method is being called. So that will be the one which will be first loaded and executed. So these static, if we apply it on a static, on a variable, then it is called as a class variable. And they are also global variables. And these, if we define any variable as static, then that will be common to every object. It is a common variable or common member to all the objects. So it generally used to refer to a common property of all the objects. And also there only single copy of the static variable will be available. So if we have one static variable A, and we have 3 objects accessing it, like 3 objects accessing it. So if one writes some value into this and 2 also write some value into this, then at that point only the value of 1 will be overridden and the value of 2 only will be available. Similarly, if 3 also writes into this value, then the value which is written by 3 will be available by all these objects. And as a default value for numbers, if the variable is a number, then the default value is 0. For Boolean, it is set as false, and for object references, it is set as null. And now, if we want to access that static variable using any static variable, then we generally use the class name to access it. Class name dot variable name. Here we will not be using the we will be always using the class name followed by the variable name. Now, if we declare any methods as static, then these methods also can be invoked without creating an object of its class. But the problem here is that they can access only other static members. These static members can be accessed by other static members only. And also this and the super keyword, which it cannot be used over static members, static methods. And to access the method name, we use class name followed by the method name. So these are the features of using static keyword in Java. Now let's look into an example of static use of static. So here we have two classes. One is static demo and the other is useStatic. The useStatic method, the useStatic class is having the main method. It has a static block also. Also, there are 4 static variables A, B, C, and D. And there are some methods with static methods call me and met. Now let's see how the working happens. So what happens here? When this program is loaded onto memory, it is the static block which will be the one which is executed first. And also at that point, all the static members, all the static variables will be initialized. So here we have A set to 3, B, C, D set to these values, and B is also declared. So B's value will be set to 0. B value will be set to 0, and A, C, and D will be set to what is as given. So when this program is loaded, before the execution of the main part, it will execute the static block. The static block will be the one which will be first executed when the class is loaded. So what happens? We'll get this statement as the first statement of output. So that is why we got this statement in our output. Similarly, since A is being initialized to 3, we get the value of A display. B is just declared. So when B is declared, its value will be set, its default value will be 0. So we have a B value displayed as 0. Then we are finding the product of A and 4 and storing it into B. So B will contain 12 now. B is setting it to 12. So the B's value is set to 12. Then it will print the statement static block left. So all these happens before the loading of the main, just when that class is loaded. Right. Now, once this static block is executed, the control will come to main. So the first statement in main is to print that statement. So it will print this statement. Once it is printing, it is calling the method meth. So meth is what? Meth is a method which is present inside the useStatic class. So because of that, meth is a static member. So even since it is present inside the class, you need not use the class name followed by it. But when we are calling the call me method, call me is present inside the static demo class. So we have to we have to create an object of it. But this call me is what? It is a static method. So we can just use the class name followed by the method name. Now what happens when you call this method meth? So to meth we are passing 42. So when 42 is being passed, it is taken on to x. So it will display the value of x as 42. A's value was 3 and B's value was 12, which we got it over here. So these values will be printed inside meth method. So on here, these 3 output, we'll get it using the meth method. After completing this part, after completing the method, it will come over here. It will start executing this. It will call me. Now, since call me is a static method, so we have to use the class name in which it exists. So call me is present inside static demo class. So the way by which we call the static demo is, call me is static demo dot call me. So inside call me, it is printing the value of C. So you get C as 42. C is being set to 42 initially, so that value will be printed. Now, we are calling the static we are displaying the static member D also, which is stored in the static demo class. So because of which we have to use the static demo class name followed by the static variable. So since we are accessing the static variable D, we have to use the class name in which it exists. So we are calling static demo with the static member, and when we display it, we get 99 since D is initialized to 99. So this is about static. So whenever we want to access any static member, we have to use the class name followed by the member name. And the static variables will always be is a shared member of the classes. It is a shared member of the classes. Next, let's look into access control. So, what do you mean by access control? It is used to protect the data from outside interference. And this is brought into use by the concept of encapsulation. So, encapsulation means it is the method by which the code and the data are bound together. It is the mechanism that binds the code and the data. So it also helps in keeping the data safe and from outside interference and misuse. So this encapsulation will provide the access control mechanism. So if we want to use any member which is present inside the class from outside it, then there are some access specifiers which we have to look into. So the 4 access specifiers available are public, protected, private and default. So if you define any variable as public, they can be accessed anywhere. That is why we always declare our main method as public, because it is being invoked by JDK. Then if we define any variable as or any member as private member, then that can be used only within that class. A default member can be accessed within the package, and the protected member can be accessed by its subclass. It can be if we declare any member as a protected member, then if we have a class which is being derived from that given class, then all those protected members can be accessed by the child class. So as I've told you, the public member can be always accessed by any other code. The main was always preceded by public modifier because it is being called outside the program by the Java runtime system. The private member can be accessed only by other members of its class. Only it can be accessed only within the class, and that by the other members of the class can only access any private member. Default means it doesn't have any access modifier as such specified, but it can be accessed within its own package. It can be accessed only within the package, but it cannot be accessed outside its package. And protected member is applicable when we follows inheritance, and it can be accessed only by the protected member can be accessed by the child class of that particular class. So if we look into the table, we have a private member which can be accessed only in the class. Default member can be accessed within the class and within the package. Protected member can be accessed within class, within the package, outside the package by only subclasses. And public member can be accessed everywhere. It can be accessed within the class, within the package, outside the package, and by its subclasses. So public member is the one which is available everywhere, and the private one is the most protected data available. Now let's look into a example, a program. So here we have a class named test, wherein it is having an integer variable a. Since it doesn't have any access specifier specified, it is default. It is it is provided with default access. Now since then we have a public variable b, this will be available, this can be accessed by everywhere, by any program. And we have a private variable c. So private integer variable c will be accessible only to the class test. Then we have two methods, setc and getc. They are also default methods, wherein this setc is accepting a variable, an integer variable, and it is setting the private variable c to that particular value, and getc will return that value to the called function. Now this class test is being accessed inside access test method, inside access test class. So we have, since this access test is trying to access the test class, we have to create an object for that. So we have an object OB is being created of the test class. Then we are setting the OB A and OB B to 10 and 20. Now A and B are what? A and B are default, and they are default and public variable. Hence, they can be easily accessed over here because these two programs, these two classes are present in the same program within the same package. So, B being public, it is easily accessible, and A being default, it can be accessed within that package. But when we try to access C member using the object, it will throw an error. An error will be shown while we try to execute this statement, because we are trying to access the private member of that object, and this private member cannot be accessed outside its class. Since C is the private member of test class, it can be accessed only by the members. It can be accessed by the setc and getc methods, but it cannot be accessed by anyone outside that test class. So when we are trying to access the private member, we are trying to access the private member by using the inside the access test, which hence it will throw an error. So if we want to access the C member, private member, we have to make use of the other methods. Now since these methods are default methods, they can be accessed inside the access test class. So we using the setC method, we are setting the value of C to 100. So this method will set C value to 100, and we are trying to display the contents of A, B and C. So we are displaying ob.a. So ob.a means it will display 10. A value will be 10. So this is our object OB. A is 10. B is set to 20. So when we call ob.b, it will display 20. And ob.getC. So getC means it will return the value of C. So C was set to 100 by using the setC method. So when you call getC method, it will retrieve the content. So C was set to 100 using the getC method. So what happens when you call getC on OB, it will take this value and return the copy of it to the called function. So whenever if we want to provide protection of data, we have to provide. You have to use access control. If that any data is defined as public, then that member can be accessed anywhere within the anywhere outside that class. And if we declare that member as private, then that is private and it can be accessed only by the members of that particular class. And the default methods, variables can be accessed within the classes in the same package. And protected members can be accessed by those classes which is inherited from that particular class. The child class can access all the protected members of the parent class. Next, let's look into the use of this keyword. So why do we use this keyword? Now, the programmers have a habit of using same names for the formal and actual parameter. So when we follow such things, there may be a confusion which is the actual class, which is the actual attribute and which is the local attribute. So in order to eliminate the confusion we make use of this keyword. So when a local variable has the same name as the instance variable, the local variable hides the instance variable. So this keyword eliminates the confusion between the class attributes and the local variable. And also it overcomes the instance variable hiding. Also we can use this keyword to invoke a current class constructor, the current class method, current class object, pass an argument into a method and pass an argument in the constructor call. So here whenever we want to this keyword will be used more on the current class which is being working on. So I'll just discuss an example of how we can use this keyword to clear the confusion between the local and formal parameter. So here we had, in the previous examples, we have discussed about the box class. In that box class, in our program, we had used W, D and H for representing width, height and depth. But there may be programmers who will be using the same name as width, height and depth, so that there won't be any confusion, so that they can understand that they can clearly make a thought of what W is meant for, what D is meant for, what H is meant for. Instead of using W, D and H, we can use width, height and depth. So generally this is the way we write. So here we will be, it is difficult to understand which is the class variable and which is the local variable. So here, this problem can be resolved by making use of this keyword. So we can, whatever object is being created, onto that object, let's say we have, this is width, this is height, and this is depth. So this object's width can be accessed like this, with this dot width. So when you call this dot width, whichever object was being invoked over there, it points on to the object which has been invoked here. So this dot width means it is referring to this part, this object. So its width is set to what is being passed on. It is set to what is being passed on. So let's say if we had passed 10, 10, 10, then that 10 will be stored over here. Then height is also set to, so this dot height means that object's height is set to what is passed from the constructor. So it will be set to 10. Similarly for the depth. So this, by using this keyword, we can resolve namespace collisions. And also, now let's look into an example of using that. So here we have a class named A with an integer variable, a double and a character, and this is the constructor for it. So we have defined a constructor also for that class A. Now we are outside that class we have another class named this K, which is creating an object of that class A and setting the values of 10, 20. Setting the values of A, B and C to these values. So when you create an object here, it will create an object OB with values A, B and C. So at this point, a constructor will be invoked. So when the constructor is invoked, the control will come here and it will set, so 10 will be passed to this A, 20.25 will be passed here, and B will be passed to here into C. So these values A are stored into this dot A. So this dot A means to whom it is referring? It is right now it is referring to the object which has been invoked here. So it is the OB which has invoked this constructor. So since OB is invoked, OB's A value, the keyword this refers to the OB. So OB's A value is set to what is passed here. So it is set to A. So it is set to 10. Then OB's, so this dot B means OB's B value will be set to 20.25. So it will be set to 20.25. Then OB's C value is set to character C. So which is storing B. So B value will be stored over here. So like this it has created an object OB. It has created an object OB. Now similarly in the next case it is creating another object OC. So you will have OC created here. OC will have A, B and C. So to OC it is passing 100, 200 and so to while in creating OC object, first parameter is 100. So A will take 100, B will take 200.25 and C will take character C. Now these values are stored into the objects instance variables. So here when it calls this dot A here, when it calls this dot A in the second case, it refers to the object OC. So it refers to the object OC. So OC's, this dot A means OC's A is set to A. So A is 100. So OC's A is set to 100. OC's B is set to 200.25 and OC's C is set to character C. Now in the next line, we are trying to, in these lines, we are trying to display the contents of it. So when you call this line, it is accessing OB.A. So OB.A is 10. So you get the output 10. Then OB.B is 20.5. So you get the output 20.5. And the OB.C is B. So we get the character B. Similarly, in this line, we are displaying the the contents of OC object. So OC.A is 100. OC.A is 100. OC.B is 200.25 and OC's character is C. So to for reference of preparing, as a reference of preparing these slides, I have taken, used the textbook Java Complete Reference by Herbert Schill, which is a prescribed textbook also. And also, we can get other points from these two textbooks, and these are some of the reference textbook for which can be followed. So in today's class, we have discussed about static fields and members. Then what is the use of access control and what is the use of this keyword. So with that, I come to an end of the today's section. We will continue in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.